Good morning, everyone, or good evening, or afternoon, or yesterday, or tomorrow, or whenever you're listening to this from. Today, in this demonstration, we are going to be investigating enthalpy. A substance energy can be measured by enthalpy. All matter contains energy. Measuring the total amount of energy present in a sample of matter is impossible. But changes in energy content can be determined. These changes are determined by measuring the energy that enters or leaves the sample of matter. If 73 joules of energy enter a piece of silver and no change in pressure occurs, we know that the enthalpy of the silver has increased by 73 joules. Enthalpy, which is represented by the symbol H, is the total energy content of a sample. If pressure remains constant, the enthalpy increases of a sample of matter equals the energy as heat that is received. This relationship remains true even when a chemical reaction or a change of state occurs. So the way we're doing it is we're going to melt down some aluminum in our homemade furnace using propane. We have a furnace that uses propane. So there we are, we cut up some aluminum. Aluminum has a melting temperature of about 650 degrees centigrade. There we are, smashing it up. We cut it up, but it doesn't take up a lot of space, so we found out very quickly that we need a lot more aluminum cans because they're going to melt down and they decrease in size. So there we are, we've stuffed it full and we got our furnace going. You can hear it almost sounds like the flame of a Bunsen burner, on a larger scale, of course. And so we're just getting it started. We put a little wood in the side so we could know that it was burning, and we just want to heat it up nice and steady, and then we'll take it to the higher level. We'll increase the flow. Here we go. I'm just showing how the design, we could limit the flow of oxygen with these little pieces of cardboard. This is where the propane is being shot into the furnace, and so we can limit the flow of oxygen that it's dragging in with it. But right now we're going to leave it open, get as much oxygen as we can. And so it's heating up, and we're just in the backyard waiting for it to heat up and doing other things. Alright, here we go. We're checking on it. I can't really get the camera in there to get the light that you need to see, but you can kind of see as I push, the cans are soft, and I can kind of squish them down, and I want to push them down as best I can to decrease the amount of air that's in between them, so we have a more dense liquid. This is the pan we used to pour ingots of aluminum last time we did it, but today we're going to use this couple-year-old dragon mold that we made a while back, just because we already have it, and we're going to go. There's another crushed can. We could just add it right into the top as more room comes in, although it doesn't fit exactly well. And that's our system, and so we want the hole not to be very big. So you got to balance how large you want the hole on top, because that's going to let energy out of the system. We're trying to contain it. So this doesn't have any pressure on it, unlike a calorimeter, which is closed. It's a closed system. This one is more open. So we would have to put our furnace into a second room and to be able to show all the energy. This is the melted aluminum, and you can see there's a bunch of slag on top, so we took a spoon and we cleared it out. But here comes, we've been waiting for about 30 minutes for this to melt, and now all of a sudden, after doing not a whole lot for a long time, you're working with this thing that's hundreds of degrees hot, and you gotta pour it. You see how beautiful it is, like looking into a mirror. We put in about 7, 8, maybe 9 cans, aluminum cans, and this is what comes out of it. The slag on top was the paints and the other things they put onto it. And so there's a little bit of copper left in there, but mostly it's just contaminants. And there we go. Now that it's done pouring, you can relax and kind of enjoy it. And you see everywhere we put these, she put the crucible down to the side and it's burning the grass because of course it's still really hot. And so there's a bubble on it, and it's actually not a bubble, it was slag, so she kind of used the tongs to pull it off. And that's our finished product there. We let it dry, or not dry, but cool off just a touch. It doesn't take very long to re-solidify it. This is only a few minutes after we had poured it. If that, maybe 2 minutes after it was poured. And even though she's wearing those giant gloves, she's afraid to touch the mold. But there it is. And quenching it in some water. Although by this point it's already fairly cool, so we probably didn't need to quench it. I'm not too sure if that added to the oxidation on it. And you see it didn't come out very clearly. We're rusty, ironically, in our smelting abilities, so it's not very sharp. But this was our first real successful attempt using the propane tank, which we had never used before. We were a little worried about trying it, but so far we haven't had any problems. We had a tiny leak, but we worked on that. We tightened all the whole system up. But obviously this isn't a closed system. Our backyard would have to be enclosed. We'd have to enclose ourselves in something like a warehouse. And then we could possibly use thermal cameras and other kinds of temperature detecting apparatus to measure all the energy in the whole event of using that foundry. And it took a good long while and it got pretty hot. I didn't have anything to measure the actual temperature, but we have other ways. We know it got to at least 650 degrees centigrade, Celsius, because that's the melting point of aluminum. So that was our first attempt. That's our first little experiment with this furnace as well. So come back for part 2 and see what we decide to do with this aluminum ingot that we've created. Thanks for joining us.